Today we're going to take a look under the covers at Photino and see a little bit about how the sausage is made. So what is Photino? It's a native window with a browser control, and that allows you to run HTML and JavaScript UIs and wrap that inside of a back end of your choice. In our case, we usually talk about .NET, but Photino native is just the native part. So it's just the Win32 part, or if you're on Linux, it's just the GTK UI part, or if you're on Mac, it's just the Cocoa UI part. So I'm going to show you the C++ code behind Photino native, and we're going to look specifically at the Windows version. So this is the Visual Studio solution for Photino native. So this is a C++ project, and there's really three files that we're going to be interested in. So Photino Windows CPP, this is the bulk of the code. This is Win32 programming. So there's this WinProc here where we're defining the message pump and all those fun things that Windows 32 programmers have to deal with. Interesting thing to look at is the constructor. So when you create a new instance of this Photino native window, this is all the code that runs. We pass in a set of Photino init params. Now this is a pointer to a struct, so this is essentially something that has all of the different parameters that we need to start up a window. And we start off just doing some basic checks on it, make sure that it's the size that we think it is. Then we do things like start copying the title out of it. We look for a start URL, so where are we going to navigate when this window comes up. Some of the parameters are callbacks. When the native Photino window is resized, for example, we can tell it to call some of our code so that we can handle that. So we'll pass in pointer to a handler. There are custom schemes. So a scheme is that part of the URL, the very first part where it says HTTP : or file : You can do custom schemes, which is something we use a fair amount. For example, you'll see app : as the starting URL for some things, app : // So we're essentially in this constructor taking all those parameters are passed and either implementing them right away or we're saving them off so that we can use them later. Then we get down to the point where we actually create the window. So this is again on Windows. Create window EX is the call that you make in Win32 when you want to create a native window. And then we'll do things like, well, if they passed in an icon file that they want to set as the icon in the upper left hand corner of the window, if they want to center the window. So we do all this stuff before we actually show the window, and then we call this show. And here's a Win32 call that actually makes the window visible on screen. And then once the window is visible, now we can start adding controls to it. So this is where we can put our WebView2 control, which is the edge control, inside the window, and we'll size it to take up the full size of the window. So one of the first things we do is check to make sure the WebView2 control is installed. Now on Windows 11 it is, on Windows 10 it isn't necessarily. If it's not installed, it'll give the user a prompt to go ahead and download and install the web control. Once we know that the web control is there, we'll call attach WebView, and this is all of the code that initializes that WebView2 control. All of this code is Windows specific. It's all Win32. It's all specific to the WebView2 control. And this code's a little bit ugly. It's a series of nested callbacks, so everything is done asynchronously, and as one part of the WebView control is initialized, when that finishes it does a callback, and that's where all this nesting comes from. You can see, for example, that this is the place we talked about custom schemes, that, you know, app : // for example. So if a custom scheme was requested, then we'll handle that custom scheme here, and we'll tell the browser control, when you see that, I want you to do this. And then you'll see down towards the bottom here, we look and see if they passed us a start URL, and we'll go ahead and navigate to that. So we have to wait till the browser control is completely initialized, and then we'll navigate to the page. So this is all in setting up the initial state of the window, and then setting up the initial state of the browser control, doing that initial navigation. Really, that's the whole function of the Photino window. So what is all this other code? Well, these are things that are done after the window is pulled up. If you want to set the window to be full screen, and all of this code is the Win32 way of making a native window full screen. Or if you want to change the title, these are all Win32 calls for making that happen. Some of these calls are specific to the browser, so if you want to change the zoom on the browser control programmatically, you would change it by calling set zoom. So that's most of the code for the Windows version of creating a native window and showing a browser control. I said there's two other files for Windows that we're really interested in. These two files are actually shared between Windows, Linux, and Mac, and that's why you see all these Linux programs and Mac programs in here as well, all the source code. Everything's just sort of put together into one solution so that they can share certain things and to make it a little bit more convenient so that all the source code is in one place. All of these Linux and Mac files are ignored when we're on a Windows machine. So if I was to build this, most of these files would be ignored. The Windows CPP file we would compile and use, and then these couple of shared files. So the first one is Photino.h. This is a header file. You can see that it's got a few if-defs in here, so this file can be used across different platforms. So if we're on a Windows platform, we're going to include the windows.h. If we're on the Apple platform, we're going to use Cocoa.h and WebKit.h. And there are a few things that'll make it specific to the operating system that you're on. When your application wants to call a Photino native window, it passes in this whole set of parameters that says this is how I want my window created and this is where I want my browser control to navigate to. So I pass things like where the window needs to be positioned, the size of the window, the initial zoom. If we have those callbacks set up where if we say resize the window and we want to be notified of that, we have to pass in a pointer to a method that's going to handle that. You'll notice that all of the strings are doubled up here. This is kind of an interesting thing. Windows has been around for a long time. Win32, even though it says 32 in the name, it can be 64-bit, it can be 32-bit, it can even be 16-bit. It can also handle strings in different ways. So when this was originally written, the call was made to start off with 64-bit Windows and Unicode strings. And Windows was the first piece that was written. In our Windows code, we're going to use this parameter, and when we're on Linux or on Mac, all that code is going to use the other parameter. The last file we need to look at is this export CPP. And again, in here you'll have some if-defs for different platforms, but for the most part, this is the public interface of the dynamic library that we're creating. So for example, here is the constructor, and this says make this public, and then it just makes a call to the actual constructor. So the export CPP and the Photino.h are reused across all the different platforms. In this case, when I compile for Windows and I call this constructor, it's actually going to pass this through to our Windows CPP file that we looked at earlier and make the call to that constructor. So what about all these other files? What about Linux CPP and all these Mac files? On this platform, they're all just ignored. If we open up the Linux CPP, for example, you can see there's an if-def Linux in here. That means that this entire thing is just ignored. It's nothing but an empty file. If I'm really developing for Linux, I'm going to open up this Linux CPP file on a Linux box in an editor, and when I want to build it, I'm going to call a completely different compiler, and that compiler is going to look at this photino.linux.cpp file, and it's going to completely ignore the Mac and Windows. So what does that mean? It means that this is the public interface. These are some things that are shared across the operating system. Everything else we redo from scratch for each operating system. If we want to add a new feature, maybe we want to do something with native menus. On Windows, a native menu shows up on the main window of the application. That's just sort of part of Windows 32. So we could implement that, and we could put some methods in here that say, let's create a first level menu, and let's create a sub menu under this other menu item. Let's fire this callback when this menu item is clicked. Now when we implement that, we're going to need to put that into this Photino.h. We're going to have to specify in this that that method exists, and then we're going to have to go to our export CPP and do something like this to ensure that that call becomes visible to the outside world. Now let's say we've done that. We've added the ability to do native menus in Windows, and then we've added it to our export CPP and our Photino.h. Next step is that we have to go into our Linux CPP, for example, and implement that call here. Even if it's just an empty call, it has to be there. Then we do the same thing for Macintosh. And then we figure out how do we implement this on Linux with GTK. So we'll figure out the GTK version of doing native menus. Then we'll do the same thing on Macintosh. So we'll open up the Macintosh code and we'll start implementing it using Cocoa and figure out, well, how do native menus work there. Now that can cause some interesting scenarios because not everything is available on Windows and Linux and Macintosh, and they're not all available the same way. Sometimes we can make things look the same on the surface level and we just implement them differently. Sometimes we're going to find something that's available on one or two of the operating systems but not on the third, and that gives us an option of saying, you know what, we shouldn't do this because it's not going to work the same across all the platforms because it doesn't work on platform X. Or we can say, you know what, we'll go ahead and we'll make it work on the two platforms that it does work on, and then when they call it on the other platform, we'll just ignore it. So we have some options on how we handle that, but we do have to have the calls available in all three versions of this. So Photino Native was actually implemented 3 different times in 3 completely different ways. We rewrote all of the code other than those couple of shared files which just have the interface in them, and we created a Windows version of everything. We started from scratch and created a Linux version of everything with GTK. We started again with Mac and created a Mac version with Cocoa. So Photino Native is really 3 different C++ programs. All the source code is jammed together in this solution, but they're really separate programs and they're compiled separate. Let's take a look at the result of all this. So if we look at the NuGet package for Photino Native, I can actually download this package, and I have a tool installed on my machine that allows you to look inside of a NuGet package and see what's in there. I can see all my information about my NuGet package, and inside in the actual contents there's this runtimes folder. And inside of that, we have a folder for each platform that it's been compiled. So we've been looking at Windows so far with an Intel processor. For a Windows x64, which is Intel or AMD, it generates a Photino.native DLL, and it also includes a WebView 2 loader control. So there's a DLL that you need to get the WebView 2 to work. And that's just going to work on this platform. So this was compiled on a virtual machine. This was actually compiled in Azure DevOps in a pipeline. We fire up a virtual machine that has everything that we need to compile this for that platform. And then it's done again for an ARM64 version of Windows, and that comes out with a Photino.native.dll that is compiled for ARM64 architecture. It's done again for Mac OS on Intel or AMD. On that operating system, it's called a DYLib, dynamic library, instead of a DLL. So our Azure pipeline has a virtual machine that runs this operating system, and it does the build for us. Now, there's no support yet for M1 and M2 chips, the ARM64 for Macs, so one of our developers actually creates this DYLib on his machine and then injects it into the build pipeline so that it can become part of the NuGet package. And we do the same thing for Linux. So there's the Intel AMD version, and on Linux these are typically called .so files, these dynamic libraries. And then there's one built for an ARM64 platform for Linux as well. So different builds using different pieces of the source code to create something that has a standard interface that is a native window with a web control in it, and this ability to communicate and send events that happen back to callbacks in your code, or for your code to call in and say something like, hey window, go ahead and minimize yourself, or hey browser control, go ahead and change the zoom level. So if I have, for example, a Linux machine with ARM64 architecture, and I put this file, this .so file on it, and I register it and mark it as executable, then I can write an application on that machine that calls this up, that makes calls into that SO file, into that dynamic library, and says, hey, open up a window with these parameters, navigate to this page, and I can get the callbacks and I can make the calls into it. So any language on any platform that can make calls into this, so if you're a C++ programmer, it's pretty easy. You make calls into the C++ library. If you're a Rust programmer, or a Go programmer, or a Python programmer, anything that can make calls into a native library can use Photino Native. But what's really interesting is if you happen to be in an ecosystem where your code can run on multiple platforms. .NET is such a platform. So if I'm running in .NET, .NET will run on Linux, it'll run on Mac, it's going to run on Windows, it'll run on ARM64 chips, it'll run on Intel chips. So if I'm running a .NET application and I can run on all these different platforms, .NET is going to load the appropriate library for me. So if I'm on Linux, it's going to load the Photino native SO dynamic library on Linux. On Windows, it's going to load the Photino native DLL library on Windows. And I'm going to make calls because I have this unified interface from my .NET application. So I'm going to write my .NET code once, and it's going to run on whichever platform I'm on. I don't know if you've done a lot of low-level .NET programming before, but if you're doing that type of interop programming, it's not a lot of fun. It's pretty low level. You're dealing with things like pointers and how do I marshal this parameter. It would be great if there was a wrapper built in .NET that sort of handled all that for you so that you didn't have to handle that, and you could just make .NET calls into a .NET library and it would pass everything through appropriately. And that's what Photino.net is, and we'll take a look at that in our next video.